Okay, so in this one, we're trying to use a graph to show that this limit doesn't exist for that function. So this function right here, if I write over here, f of x equals x squared minus 4 over x minus 1. Now, technically, I could put this on a non-calc part of a test, because you could graph this by hand, x plus 2, x minus 2, over x minus 1. And then from the denominator, you can tell that there's a vertical asymptote at x equals 1. And from the numerator, you can tell that you have zeros at x equals negative 2 and positive 2. And from that, you can make a sign chart. Negative 2, 1, 2. These were zeros. This was a vertical asymptote. We're plugging into f. And if you did a sign chart, let's see, if you plug in like negative 4, you get negative, negative, negative. That's going to be a negative here. And then this ends up being a positive if like you plug in 0. And then you get a negative here and a positive here. And so based on that, here's a rough sketch of our graph. So vertical asymptote at 1. Zero at 2. And another 0 at negative 2. And it starts out negative and goes positive, so it's going to do something like this. And then it's from here it's negative and goes positive, so like that. So if I'm looking around x equals 1, then I need to look at the left side and the right side of 1. So limit as x goes to 1 from the left of f of x. Well, on the left side it goes up to infinity. Ugh, sorry, the pen's not working here. Infinity. And then the limit as x goes to 1 from the right of f of x is negative infinity. And these aren't the same, so we can say limit as x goes to 1 f of x does not exist. Which actually, you could determine that just from any one of these by themselves. If you have an infinite limit, that means that the limit doesn't exist. But usually it's more useful to say infinity because that gives you a little more information about what the graph is doing.